Your shadow is lying to you. It has been lying to you every single day of your life, and nobody, not your physics teacher, not your textbook, not any documentary you have ever watched, has told you the full truth about what that dark shape on the ground actually is. They tell you light travels in straight lines and your body blocks it. That sounds like an explanation. It explains almost nothing. It is like saying music is air moving. Technically accurate, completely empty. When you actually understand what a shadow is, what it is made of, what it is drawn on, what it is measuring without your permission, you will never look at the ground beneath your feet the same way again. And I mean that precisely, not poetically. By the end of this, you will understand why your shadow knows things about the universe that took humanity thousands of years to figure out. There is a moment coming in this conversation that I want you to be ready for. It concerns what your shadow is actually doing while you stand still. The answer is stranger than the question, much stranger. But let us begin somewhere simple. Look down if you can, or simply remember the last time you did. There is a dark shape beneath you. It has roughly your outline. It shifts when you shift. It shrinks at noon and stretches at dawn. You have seen it 10,000 times and thought almost nothing of it. Here is the first thing most explanations get wrong. They call a shadow an absence, a nothing, a place where light is missing. And yes, in the most literal sense, a shadow is where light does not reach. But think about what that actually requires. For light to be missing in one precise location, something had to interrupt a journey that began, in the case of sunlight, approximately 150 million kilometers away. Your shadow is the end of a story that started 8 minutes ago at the surface of the sun. That shadow has no weight, no texture, no atoms. You cannot pick it up or put it in a jar. And yet here's the first strange thing. A shadow can move faster than light. Or rather, let me be more precise, because this is worth getting exactly right. Imagine a lighthouse beam sweeping across a distant wall. As the beam rotates, the point of light drags across the wall faster and faster the farther the wall is. Now replace the wall with the moon 384,000 kilometers away, and sweep the beam quickly enough. The edge of the shadow, the boundary where light ends and darkness begins, crosses the lunar surface faster than 300,000 kilometers per second. The speed of light, the supposed universal speed limit. Nothing physical is moving that fast. No object, no particle, no signal. But the shadow outruns all of them, because a shadow is not a thing traveling through space. It is a shape that space is drawing, and that distinction is the key that unlocks everything else. Think of it this way. A shadow is not a thing. It is a shape that light draws around you. Hold that. Because if a shadow is pure geometry, a shape, not an object, then it must obey the rules of geometry. And this is where a Greek librarian who lived 200 years ago becomes relevant. His name was Eratosthenes, and he did something that should have been impossible with the tools available to him. He measured the size of the entire Earth using 2 shadows and a letter from a friend. In 230 BC, Eratosthenes learned that in the city of Syene, in southern Egypt, the sun at noon on Midsummer's Day shone directly down a deep well. No shadow at the bottom. Sunlight hit the water perfectly, vertical, straight down. But in Alexandria, 800 kilometers to the north, a vertical stick cast a shadow at the same moment. A clear, measurable shadow angled away from the stick. He measured that angle, 7 degrees, 1/50th of a full circle, which meant the Earth's surface had curved by exactly that amount between the 2 cities. So he multiplied the distance between them by 50 and arrived at the circumference of an entire planet. His answer was within 2% of what our satellites measure today. Remarkable. 2 shadows, 1 number. A planet measured. But here's what I want you to notice, because this detail will matter again before we are finished. The shadow in Alexandria knew the Earth was curved before anyone standing in Alexandria did. The shadow was carrying information about the shape of the surface, encoding the geometry of an entire world, and casting it faithfully on the ground every single day, waiting for someone patient enough to read it. A shadow on the ground was the first map of the sky. Now, what Eratosthenes discovered by accident, Einstein would discover by necessity. Because the geometry a shadow obeys is not just the geometry of Earth's surface, it is something older and stranger than that. The surface a shadow is drawn on is not simply the ground. It is not simply space. And to understand what I mean, you need to question something you have never once questioned in your entire life. What exactly is a shadow traveling through? You have always assumed the answer is obvious. A shadow falls through air and lands on ground. Simple, visible, unquestionable. But air is not what I mean, and ground is not what I mean. I mean the deeper medium, the thing that both the air and the ground are sitting inside, the thing that everything in the universe is sitting inside. We call it space, and we treat it, without even realizing we're doing it, as a container, an empty box that holds things. Stars go inside it. Planets go inside it. You go inside it. The box itself, we assume, just sits there, passive, flat, indifferent. Einstein's first strange gift to the world was showing that the box is not passive. The box is not flat. The box responds. When you walk through a crowded room and squeeze between two people, the gap between them is not nothing. It has a shape. It can widen or narrow depending on how the people around it are standing. Remove one person and the gap changes. Add someone heavy in the corner and everyone shifts slightly without noticing. Space behaves like that gap, except the room is the entire universe, and the things changing its shape are not people. They are masses, stars, planets, you. Every mass in the universe leans into space the way a warm hand presses into soft clay, not just downward, but in every direction simultaneously, reshaping the medium around it. Your shadow is not falling on a flat surface. Your shadow is being drawn on a surface that every object in your vicinity is gently, continuously deforming. What I really mean is this. Space does not just hold your shadow. Space is the medium the shadow is drawn on. And that medium is not flat. This should feel wrong. It felt wrong to every physicist who first encountered it. Your intuition was built for flat floors and straight walls, for catching things thrown at you and judging whether a step is level. It was not built for reading the shape of a four-dimensional surface. So if something in you is resisting, that resistance is correct and healthy. Push through it anyway, because in 1919, a British astronomer named Arthur Eddington sailed to a small island off the coast of Africa to take photographs during a total solar eclipse. He was not there to look at the sun. He was there to look at the shadows. Specifically, he was looking at stars whose light passed close to the edge of the sun on its way to Earth. According to the old understanding, the flat box understanding, that light should have traveled in a perfectly straight line. The stars should have appeared exactly where our charts said they would be. They did not. Stars that should have been tucked behind the sun were visible. Their light had bent around it, curved by the sun's mass, reshaping the space it traveled through. The deflection was 1/75 arcseconds. A shift so vanishingly small, it is like watching a human hair move sideways when viewed from the length of a football field. And yet the instruments caught it. Precisely. Exactly as Einstein had calculated. The shadows of those stars had moved. The darkness behind each one was displaced, not because anything pushed the light, but because the surface the light was drawing on had curved, and the shadow followed faithfully. The way a line drawn on that tablecloth I want you to imagine follows every wrinkle when the cloth moves. Picture a white tablecloth, perfectly flat. You draw a straight line across it in ink. Now someone pushes their fist up from beneath the center of the cloth. The line distorts, bows upward, curves around the fist, continues on the other side. The ink did not change. Your hand did not move, the surface moved, and the line obeyed. Eddington's stars were the ink, the sun was the fist, and the bent path their light traveled was the shadow, following the only geometry available to it. Your shadow obeys that same geometry every moment of every day, drawn by the same light that bent around the sun in 1919. On the same curved surface, you have simply never had reason to notice. Because the masses nearby, the Earth, the Moon, the distant Sun, curve space gently enough that the distortion in your shadow is too small for your eyes to catch. But it is there. It is always there. Now here's where it stops being a beautiful physics fact and starts being something personal. Something happening inside your body, inside your history, inside the very moment you are living right now. Everything I have shown you so far, the bent starlight, the curved surface, the shadow obeying geometry, it cannot refuse. That was the ground beneath the building. What comes next is the building itself, and when it is finished, you will understand that your shadow is not doing what you have always believed it is doing. Not even close. Space and time, we treat them as separate things. Space is where you are. Time is when you are. Space is the room you are sitting in. Time is the clock on the wall. They feel completely different. One you can point at, one you can only wade through. But here is an observation that does not fit that picture. The faster you move through space, the slower you move through time. Not metaphorically. Not as a thought experiment. Physically. Measurably. If you get up from where you are sitting and walk across the room, time passes very slightly slower for you than for someone who stayed still. The effect at walking speed is too small to feel, but it is real. It has been measured, and it means that space and time are not two separate things. They are two directions of the same surface. Einstein called it spacetime. One word, one surface. And your shadow, which we have established is a shape drawn on a surface, is drawn on this one. Not just on the floor. On space-time itself. Think of pressing your thumb into warm bread. The indentation does not just go down. It spreads slightly outward, pushes the surrounding dough up at the edges, creates a depression that has shape in every direction at once. Mass pressing into space-time does something like that. It dents in all four directions simultaneously, in space and in time together. Your shadow lives in that dent. It has always lived there. You just had no name for the surface it was falling on. Are you beginning to feel the shape of where this is going? Stay with it. We are very close to something. In 1908, a mathematician named Hermann Minkowski, who had once been Einstein's professor and had, by his own admission, considered the young Einstein a lazy student, stood before a conference of scientists and said something that stopped the room. It said, henceforth, space by itself and time by itself shall sink into mere shadows. Only a union of the two shall preserve independence. He used that exact word. Shadows. He meant it as pure mathematics, a technical statement about reference frames and coordinate systems. But the word he chose was prophetic without meaning to be, because what he was describing in the language of geometry is what I am now going to show you in the language of your own experience. You are always moving through space-time. Even right now, sitting perfectly still, you are moving, not through space, you are stationary relative to the room around you, but through time. You are moving through time at the maximum rate available to anything with mass, which is roughly 1 second of experienced time for every second that passes. That sounds like a tautology. It is not. It means something specific and strange. An astronaut who spends 6 months aboard the International Space Station returns to Earth 0.007 seconds younger than they would have been had they stayed on the ground. Not metaphorically younger. Not philosophically younger. Their cells have divided fewer times. Their heart has beaten fewer beats. A shadow cast during those 6 months in orbit has a slightly different history than the shadow of someone who stayed home. The two shadows belong to two different paths through space-time. They are the same length on any given day, but they are drawn on surfaces that time has treated differently. And light, the thing that casts your shadow, moves through time at a rate of 0. Light does not age. A photon leaving the sun does not experience the 8 minutes it takes to reach you. From the photon's perspective, if we can even use that word, it departs and arrives in the same instant. It is frozen in its own moment while crossing 150 million kilometers of universe. Your shadow is cast by something that does not experience time, drawn on a surface that curves through time, and it falls on a ground that is itself moving through 4 dimensions every moment, which means the shadow you think is following you, trailing obediently behind you across the pavement, Doing nothing except marking your outline is doing something far stranger than following. And this is precisely where everything we have built together lands. Your shadow is not following you, you're moving through it. Still. Strange, the shadow is not a passenger dragged behind you across the ground. It is a fixed shape in the geometry of space-time, a gap in the light that exists because of where mass is, where time flows, where space curves. You move through the universe continuously, through space and through time simultaneously, and the shadow is what the universe records of your passing. It is not yours. It is not attached to you. It is the universe's notation for the fact that you were here, in this geometry at this moment, bending the surface just enough for light to record it. That is not a metaphor. That is what a shadow is. Think about what this means for the simplest version of the experience. You stand in sunlight. A shape appears on the ground. You have always felt instinctively that the shape belongs to you, that it is a kind of portrait, your outline, your companion through the day. But the shadow does not know you. It knows geometry. It knows where light cannot reach because mass has occupied that space in space-time. You are the mass. The shadow is the record, and records do not follow their subjects. Subjects move through the records they leave behind. A sundial is not measuring the sun. It is measuring the curve of space that makes the Earth orbit it. Every sundial ever built, every stick pushed into the ground in every civilization in all of human history, was a machine for reading the geometry of a curved universe. The shadow moved across the dial, not because the sun was traveling across the sky, but because the Earth was traveling through space-time, orbiting along the curve that the sun's mass had pressed into the surface of reality. The shadow was never telling time. It was telling geometry. We just read it as time because geometry and time on that surface are the same thing. Go back to the beginning of this conversation for a moment. Not the beginning of the physics, the beginning of the experience. You looked down at your shadow, or you remembered looking down at it. A dark shape on the ground, roughly your outline, doing what it always does. Following, waiting, shrinking and stretching with the hours. You have seen it so many times it became invisible, the way you stop hearing a clock ticking in a room you live in. The shadow was always there. You simply stopped asking what it was. Now look again. That shape on the ground is a record of bent light crossing a curved four-dimensional surface, cast by a body moving through space and time simultaneously, on a medium that every nearby mass is continuously reshaping. The shadow has not changed. You have changed. You now have the language to read what was always written there. And here is what makes this beautiful rather than merely strange. That story did not begin with Einstein. It did not begin with Eddington on his island in 1919 photographing displaced starlight during an eclipse. It began with a man in a library in Alexandria 2,200 years ago, holding a letter from a friend in a city 800 kilometers south. Eratosthenes did not set out to prove that shadows encode the geometry of space. He set out to answer a simpler question: how big is the Earth? But the method he chose, two shadows, one angle, one multiplication, accidentally demonstrated something that would take humanity 2 millennia to fully understand. The shadow in Alexandria was not just measuring the distance to Syene. It was measuring the curvature of the surface it was drawn on. It was doing at the scale of one planet exactly what Einstein would later show happens at every scale in the universe. That 7-degree angle between two shadows was not just a clever trick for calculating circumference. It was proof that shadows are faithful readers of geometry, that they do not lie about the surface they fall on, that if you know how to ask them, they will tell you the shape of the world. Eratosthenes didn't measure the Earth. The shadow did. He just read it. We can do what Eratosthenes did now with satellites accurate to centimeters. We can measure the bending of starlight around the sun to precision that would have seemed like fantasy in 1919. We can track the aging difference between an astronaut and a ground crew member to within microseconds. The measurements have become extraordinary. The shadow has become readable in ways Eratosthenes could not have imagined, in ways even Einstein only partially anticipated. But here is what we cannot yet tell you. We can calculate exactly how mass curves spacetime. We can predict where your shadow will fall near any object of any mass to remarkable precision. What we cannot tell you is why the universe is structured so that mass curves geometry in the first place. Why the surface we call spacetime responds to mass the way warm bread responds to a thumb. Why the rules are these rules and not some others. That question sits at the outermost edge of what physics currently knows. We are still walking toward it. The shadow points in the direction we are walking, but the destination is not yet visible. You have been casting shadows your entire life. Every one of them was a measurement. Every one of them was encoding the geometry of the surface beneath you, the curve of the spacetime you were passing through, the precise location of your mass in a four-dimensional record that the universe keeps. Whether you are paying attention or not, you ignored them. We all ignored them. It is perhaps the most understandable thing in the world to ignore something so ordinary. But ordinary, in physics, is almost always a disguise. The most familiar things are familiar because we encounter them constantly. We encounter them constantly because they are fundamental, and fundamental things, looked at with sufficient patience and precision, almost always turn out to be stranger and more beautiful than their surface suggests. Your shadow was never ordinary. It was never just a silhouette. It was never just darkness. The shadow you ignored this morning was the most honest thing in your field of view. It was not darkness. It was geometry, written in light, not a silhouette, not a trick of light, a confession.